So today we will study about the semiconductors and the energy bands in semiconductors. Okay, see, semiconductors are the devices whose resistivity or conductivity lies between insulator or conductor, right? It means that semiconductor sometimes behaves as insulator, they don't conduct electricity, and semiconductor sometimes behaves as conductor which conducts electricity, right? So what is the criteria behind this changing behavior, that we will understand. That is easily described by this energy band diagram. Alright, see, these three are the energy band diagram of insulator. This is for insulator, this is for conductor, and this is for semiconductor. I have written insulator, conductor, semiconductor. Okay, now see, in every material there are two bands. One is valence band, second is conduction band. Okay, so any material which is conducting electricity, that happens when the electrons from valence band are going in the conduction band, right? Unless the electrons are in valence band only, then that material don't conduct electricity. Okay, so these two bands in insulator are at a great separation, right? This energy gap, this is your energy gap, which is denoted by E and is called as forbidden energy gap. All right, it means that if the electron is there in valence band and it wants to go into conduction band, then he needs some kind of energy, and that energy is given by light, by heat, or by applying current. Okay, so some kind of energy is needed, and in after that process, when the electrons get energy, then they get excited and they jump from valence band to conduction band, right? So what happens in case of this insulator, this gap is very high. All right, this energy requirement to jump the electron from valence band to conduction band is very high, and that is greater than 3 electron volt, right? So this is not possible. That's why the insulator don't conduct electricity. All right, now come to conductor. In conductor, conduction band and valence band both are overlapping. See, this line portion is the overlapping region. It means the electrons in valence band are also in conduction band. That's why conductors easily conduct electricity, right? Now come to semiconductor. See, in semiconductor both these bands are separated, right? But this energy gap, EG, forbidden energy gap, this is very less, right? So this is less than 3 electron volt. So if we are able to supply any kind of supply energy to these valence band electrons, then they can jump to conduction band and then it starts conducting electricity. That's why this semiconductor sometimes behaves as insulator and sometimes it behaves as conductor. This is the main reason. Alright, and the thermal energy which we are providing to the electrons, that thermal energy is given by this formula, calculated by this formula KT. Thermal energy equal to KT, where K is your Boltzmann constant and T is the absolute temperature, the temperature change which takes place when we are supplying the energy. Alright, so this semiconductor, conductor and insulator, this is the difference between the working property of a semiconductor, insulator and conductor. Alright, I hope you have understood this topic. This is the basic and the most important explanation for semiconductors, why they are different and how they are different from insulators and conductors. Alright, the two naturally available semiconductors are your silicon and germanium. Alright, these are the two naturally available semiconductors. Obviously there are more artificial semiconductors also, right? We will study them in later topics, but naturally available semiconductors are your silicon and germanium only. Alright, so now if you have any doubt regarding this energy band topic, then you can ask in the comment section below. Otherwise, if you like the video, then subscribe the channel. Okay, thank you.